For customer managed symmetric keys, KMS uses envelope encryption. But let's understand what is the need of envelope encryption here. So imagine you have million of files or objects to encrypt, and you have symmetric key, means you will use same key to encrypt and decrypt both. Now if you encrypt all objects using same key, and somehow key got compromised, then all your objects are compromised, because same key can be used for decrypting all of the objects. Another thing you can do is you can keep separate symmetric key for each object. But problem with that approach is that it's not scalable, because in that scenario you have to manage 1 million keys, which is a big overhead. Before going through how envelope encryption solves these issues, let's go through this example. Suppose I want to give a box to my friend, and I don't want him to open the box without my permission. So what I can do, I can lock the box and give both key and locked box to my friend and expect that he will not open it. But still he might open the box, or even he might lose the key and someone else can use that key to open the box. Another thing that I can do is that I can lock the box and keep key with me, give only locked box to my friend. But this scenario looks good for single person. Suppose I have 1 million person, then I have to keep 1 million keys with me and also keep them secure, which is a big headache. Now to solve this problem of sharing box, I can use envelope encryption. So what I can do is that I can lock the box using key like previous scenario, but this time I can encrypt or lock the key itself using my own super secret key, which I keep in maybe in some super secret place, and then I can destroy the original key which I used to lock the box. Then I can give this logged key and locked box to my friend, and he will not be able to open the box. Whenever he want to open the box, he have to come to me and ask to unlock his key so that he can open the box. And I can do this with all of my friends. I have to just keep my super secret key secure. Now let's go to definition of envelope encryption. In envelope encryption, we encrypt the message or object using a key. Also, we encrypt the key using some super secret key. Once we have encrypted message and encrypted key, we discard this original key and store just encrypted key and encrypted message together. Later, when we want to decrypt, we can again use this super secret key to restore this original key and unencryptable message. Coming back to definition. So in envelope encryption, key used for encryption of plain text is encrypted or enveloped itself by super secure master key, and then both encrypted message and encrypted keys are stored together. And this helps to achieve centralized key management and auditing. Now let's see how envelope encryption solves the problems which we discussed initially. So the first problem was that if we use same symmetric key for all objects, then all objects are in danger. But if we see a diagram here, for each object we can spawn this key and use separate key for each object. Another problem was that if we use separate key for each object, then in our key store we have to store all those keys and secure them. And that was a big problem for scalability. But if we see here, just after encryption, we are discarding this key and using super secret key to create encrypted key, and encrypted key stays with the object. So if object is encrypted and stored in S3 bucket, then encrypted object and encrypted key will be stored in S3 bucket. In our KMS service or in our key store, we have to only store our super secret key. So this solves the issue of scalability as well.